A very good morning to Encik Hafizi bin Mustafa. We are from Group 2 and our group members are Kitisharan anak lelaki Murali, Sneha anak perempuan Prabhakara Rao, Harini anak perempuan Murugan, and myself Kashina Nair anak perempuan Balakrishna Nair, and my registration number is 33 DCE 20F1026. Today we are going to do a mathematics presentation and we would like to present question 2. First and foremost, I would like to talk about the theory for differentiation. Differentiation is the process of deriving f prime x from fx. Differentiation enables us to find the gradient at any point. What we get when we differentiate is called the derivative and it is written as dy over dx. Besides, differentiation is the technique used to find the rate of change of function and the gradient of a curve.
Hi, I'm Sneha. My registration number is 33DCE20F1032. This is the question given and it consists of Roman A, B and C. 2A. Draw and label the correct diagram of the problem. To solve this problem, we will use our standard 4-step related grades problem solving strategy. The figure. Let x be the horizontal distance in feet from the wall of the bottom of the ladder. Let y be the distance in feet from the ground to the top of the ladder. According to the instruction given in the question, x will be 8 feet and y will be 15 feet. To get the value of y, we have to use Pythagoras theorem. And also there's a 17 feet ladder leaning against a building.
My name is Kirtiswaran Analalaki Murali and my registration number is 33 DCE 20F 1024. Let us see the second question. B. How fast is the top of the ladder sliding down the wall of the building? First step. Using Pythagoras theorem, find value y, which is z square equals to x square plus y square, and the final answer of y is 15 feet. Second, state the relationship between x and y, which is x square plus y square is equal to 17 square, and take the derivative with respect to time of both sides of the equation. Finally, to get dy over dt, substitute x equals to 8 feet, y equals to 15 feet, and dx over dt is 3 feet per second. And the final answer of dy over dt is negative 1.6 feet per second.
Good day to everyone. I'm Harini Murugan here. My MATIS number is 33DCE20F1031. So now I'm going to explain my part, which is 2C. The question for 2C is how fast is the top of the ladder sliding down the wall of the building if it is sliding at 5.5 feet per second? The answer must be given in centimeter per minute. So the first step for solving this problem, we must draw a picture of physical situation where we already done in 2A. Second step is write an equation that relates the quantities of interest. Be sure to label as a variable any value that changes as the situation progresses. Don't substitute a number for it yet. In this situation, both the x and y changes as the ladder slide. So we will leave both quantities as variables. To develop your equation, you will probably use Pythagoras theorem. We are using Pythagoras theorem is because the problem is dealing with the right triangle. Furthermore, we need to relate the rate at which y is changing, dy dt, to the rate at which x is changing, dx dt. And so, we first need to write down the equation that somehow relates x and y. While x and y changes as the ladder slide, the hypotenuse of right triangle shown is always equal to the ladder's length, which is 17 feet. Hence, the Pythagorean theorem is applied. A relationship between x and y is x square plus y square equals to 17 square. That's it. That's the key relation we need to be able to proceed with the rest of the solution. Now, step 3. Take the derivative with respect to time of both sides of your equation. Differentiate x square plus y square and differentiate 17 square. End of differentiating, you will get x dx per dt plus y dy per dt equals to 0. By the way, the last 3 steps are already explained in the previous question. However, I still wanted to explain to avoid any confusion in implementation and for well understanding too. So now we proceed to step 4. Step 4. Solve for the quantity we want. The question is asking us to find dy dt at the instant when x equals to 8 feet and dx per dt is equals to 5.5 feet per second. So let's solve the preceding equation for dy dt. X dx per dt plus y dy per dt equals to 0. Since we want d1 per dt, so equals to negative x over y dx dt. To complete the calculation, we need to know the value of y at the instant when x equals to 8. Begin subproblems to find the value of y at the instant when x equals to 8 feet. We can find the value by using the Pythagorean theorem. So, when we use the Pythagorean theorem, we will get x equals to 15 feet, which is already done in previous question 2, this part. Just substitute all of the known values into the equation. And once you substitute all the value, you will get negative 8.8 feet per second. Before we finalize our answer, we must change the unit to centimeter per minute as they requested. So once we change, we will get this answer. That's the answer. The negative value indicates the top of the ladder is sliding down the wall in the negative y direction. That's all from me. Thank you.
At the end of the presentation, we learned about how to solve the differentiation of algebraic equation and how to solve the differentiation related to story problems. This is the end of our presentation. Thank you very much.